This is a recording of the talk I recently gave at the Association of Field Ornithologists, the Society of Canadian Ornithologists, and the Wilson Ornithological Society 2024 joint meeting in Peoria, Illinois. My name's Dan Shustack. The presentation I'm giving is called Using Motus to Determine Dark-eyed Junco Migration Strategies. This is a very brief overview of that project that's still ongoing. My contact information is at the end. If you have any questions, there's definitely some stuff I'm going to kind of jump over pretty quickly about the technology of Motus and some other background natural history information on dark-eyed juncos, but totally feel free to shoot an email if you have any other questions. By starting out, there's a bunch of people who have contributed to this project over the years, and in particular, I just want to highlight the work of Todd Allgaier and the Northeast Motus collaboration. Most of the detections of the juncos that I've tagged have been on Motus stations installed by Todd Allgaier, and the one station that I have put up was definitely based on heavy consultation and footwork and on-the-ground installation by Todd, and ongoing support from Todd, just as I'm muttering, kind of sputtering my way through working with the Motus technology. And this project, the Junco project at MCLA, has been ongoing since 2017, and there's lots of individuals and students in particular who have helped out with this project over the years. Recently, earlier this summer, a book by Ken Kaufman came out, and I heard an interview he gave on the ABA podcast about that book. And that book was highlighting some of the historical information about ornithology in North America. And that kind of got me curious to go and look at some of the historical literature about what we know and when we knew it about Junco, dark-eyed Junco migration. And we don't have written records, but the best we can tell is that the Native Americans knew about the movements of the Juncos, or what were previously called, and still are called, snowbirds, in that they noticed them coming and going each year, that there was this seasonal appearance of the snowbirds. Especially to the southern portion of their distribution, during the winter, they provided a food source for the Native Americans, especially when the snowbirds or the Juncos formed these large flocks. So when we get to written history, the first account that I could find of written records of the dark-eyed Junco or the snowbird was in 1709 by John Lawson, and he published this book in England, and it was pretty popular. And here's what he wrote about the snowbirds. He said, "The snowbirds are most numerous in the north parts of America where there are great snows. They visit us sometimes in Carolina." So Carolina was a broader area than what we think of it today, but the southern part of what's now the United States. "They visit us sometimes in Carolina when the weather is harder than ordinary." One of John Lawson's fans was Mark Catesby. Catesby, also English, spent some time in what's now the southern part of the United States, and he wrote a book called The Natural History of Carolina, Florida, and the Bahama Islands, and he wrote some things about the snowbird as well. And this is an illustration from one of his later editions. And this is what Mark Catesby said about Junco migration. He said, "In Virginia and Carolina," so again, Mark Catesby is making observations in the southern part of the United States, or what's now the United States. "In Virginia and Carolinas, they appear only in winter, and in the snow they appear most. In summer, none are seen. Whether they retire and breed in the north, which is most probable, or where they go when they leave these countries in the spring, is to me unknown." So fast forward several decades, we get to Alexander Wilson, who many have considered the father of American ornithology, and in particular he wrote a book called American Ornithology, published in the early 1800s. And Alexander wrote this, among other things, about the snowbirds. "Their migrations extending from the Arctic Circle, and probably beyond it, to the shores of the Gulf of Mexico, spreading over the whole breadth of the United States, from the Atlantic Ocean to Louisiana. How much farther westward, I am unable to say." So Alexander Wilson also making his observations in the southern portion of the Juncos range, specifically Pennsylvania. So he was only seeing it during the winter. John James Audubon, also making observations in the southern portion of the Juncos range, specifically during the winter, writes this shortly, a couple decades after Wilson. "This is one of our winter visitants from the north, which, along with many others, makes its appearance in Louisiana about the beginning of November, to remain a few months, and again, when spring returns, fly off to seek higher latitudes, a place in which to nestle and rear its young." So we've got Wilson and Audubon and Catesby all noting this migratory behavior of the Juncos. They're showing up in the southern portion of the United States for the winter and then disappearing to points farther north, perhaps the Arctic, even up to the Arctic Circle. Well, let's fast forward a little bit more, a couple more decades into the late 1800s, and now we start to get into what we would recognize today as the scientific ornithological literature. 1886, I believe, is the second year that the scientific journal called the Auk was in publication. And William Brewster, another famous American ornithologist, wrote this article where he was describing his observations going into western North Carolina. So western North Carolina gets into the mountains, the Appalachian Mountains, into the region where there's large national forests today, and also the Great Smoky Mountains in western North Carolina. And when he's doing his expedition, he's specifically going during the breeding season. So this is not the overwintering period. This is now the breeding season. So he goes into the mountains and he finds breeding juncos in the Appalachian Mountains. And he describes these differences between this northern junco, which had been seen by other ornithologists earlier, Audubon, Catesby, Lawson, just during the winter. He describes this as the northern junco that only shows up in the south during the winter, and then the Carolina junco, which is there breeding in the mountains of western North Carolina. Previously, these two differences, these two morphs, have not been described. Later, this southern junco, breeding in the mountains of Appalachia, is later called a subspecies carolinensis, and I'll use some of that terminology, carolinensis or Carolina junco, and the northern junco is recognized today as the subspecies hyemalis. There are morphological differences between these two different forms. The southern junco, the carolinensis, is larger versus the northern junco. Also, its bill is more bluish or dark horn color, so noticeable color differences in the bill, the northern junco having a pink, pale bill. The overall color of the plumage is lighter in the Carolina junco. It's bluer and more uniform versus the northern junco. Northern juncos can look pretty similar, but when you start to look at bunches of them, you see a lot of variation in the grays and some browns mixed in that just aren't really found in the carolinensis. And Brewster cites the local, what he calls the mountain people, who believe that this junco subspecies, the carolinensis, winters in the valleys and moves back upslope to breed. So he's describing this migratory behavior, and Brewster, quoting Brewster, he says, "Thus it is doubtless a local and essentially resident form. The carolinensis is present on its breeding area throughout the year, or maybe it moves up and down the mountains like the local mountain people believe it to do." Well, let's jump forward another 100 years into the late 1900s. So actually in the 1970s and early 80s, a scientific research project on the migration of the Carolina junco is conducted again in western North Carolina in Great Smoky Mountain National Park. It says eastern North Carolina. It's actually in western North Carolina in the breeding area. And it's a banding study. So these authors actually band hundreds and hundreds of juncos during the winter, and they look for them breeding in the summer. And they confirm altitudinal migration in this carolinensis subspecies. So they band them in the summer and winter, and then they notice them staying in those same territories throughout the year. And they confirm this residency behavior, and they also confirm, because they banded over different altitudes, different elevations along the mountain, that the carolinensis, some of them were actually moving up and down, just like those mountain people had thought was happening decades earlier. And specifically, they found that about 35% of the Carolina juncos stayed within a 200-meter area. So between winter to summer, they were found within 200 meters. Potentially even more than that were found a greater distance away, but that's the kind of the search area they had. So this brings us to what is our current understanding of junco hyemalis migration in eastern Canada and the U.S. So I'm going to use this red line here to demarcate the southern subspecies, approximately where it is, at least historically. So to the south of this red line here in southern Pennsylvania, this is the southern carolinensis subspecies. So this is where we have year-round residents and altitudinal migrants. To the north of this red line is where we have the northern subspecies, the hyemalis subspecies. If you go up into Canada, this area is shaded orangish, peachish. That part of the range map here is showing where all of those juncos migrate. So all of this area where they're found breeding, then those juncos all move southward during the winter. And then we have this area shaded purple in between. So between the red line and up into the orange, juncos are found in these areas year round, but we don't really know if they're exhibiting altitudinal migration, residency, or latitudinal migration. So it's possible that the juncos in this area are being replaced by juncos even farther north during the winter, and then these juncos in the New England, Mid-Atlantic, Southern Canada are actually moving southward. We just don't really know what they're doing. So that's why I have a big question mark there. So that brings us to the region where I'm doing my work, is in the western Massachusetts in the Berkshire Mountains. This is part of the Appalachian mountain chain. Ecologically, it's very similar to the habitats inhabited by carolinensis subspecies in southern Pennsylvania and southward. And so, for example, some of those similarities relate to the mountain and valley characteristics. So if we consider those areas specifically in the winter, the valleys remain warmer than the mountains. The mountains are colder by a couple degrees Fahrenheit. In the valleys during the winter, there's more open ground. Juncos forage on the ground, so there's more potential foraging area. But in the valleys, there are no breeding juncos during the summer. There are only non-breeding juncos from about September through late April. The mountains, though, have breeding juncos above about 500 meters, and they also, around that 500 meters and a little bit higher, but not to the tallest peaks, also have overwintering juncos. So we have juncos in the mountains year-round. Are those the same juncos in summer and winter, or are those winter juncos replacing the breeders, and the breeders are moving south? So that brings me to describe my long-term research goals. And I'm just going to focus on number 1 today, where I'm trying to describe the migratory strategies of dark-eyed juncos and populations between those northern obligate latitudinal migrants to the north, the hyemalis subspecies to the north, and the non-migrants, the carolinensis, to the south. So what are those migratory strategies in between those areas? And I've been working on this in various approaches with students over the years, using banding, feather isotopes, and what I want to talk about now is the Motus tagging. So how does the Motus tagging work? So the idea with Motus is it's an automated radio-telemetry system. So the Motus station, on this little cartoon that I'm showing here, that we put there are towers dotting the landscape. There are literally hundreds of them across the Northeast. And then these Motus stations have a potential or nominal detection distance out to 15 kilometers. So what my general approach is to find overwintering juncos that are near Motus stations, put radio tags on them. Those radio tags are detected by the Motus station, and then if the junco stays there into the breeding season, it'll continue to be detected by the Motus station and thus confirm residency. Or if the junco flies away and is detected by a Motus station somewhere else, then that would confirm movements and potentially latitudinal migration of those juncos. So I specifically tagged overwintering juncos. So I banded and tagged overwintering juncos, so I knew one end of their annual cycle, specifically where they're overwintering. And then the idea was to use the Motus technology to confirm the other area of their, at least hint at their other areas where they're overwintering if they've moved away. So nanotag overwintering juncos near a Motus station. And nanotag is just another name for the technology used to put the radio tags that are specifically detectable by the Motus station. And then if they stay within that detection area of the Motus station, we know they're residents from winter to summer. Or if they fly away and are detected by other stations, that confirms that they're migrants. And the detection range of the Motus station is up to 15 kilometers. And since carolinensis residents were found within 200 meters of the banding location, it seems like a pretty good idea here, since this can potentially go out to 15 kilometers. So along with many students over the years, we captured juncos at winter bird feeding stations with potter traps or mist nets if the weather is particularly good. I put color bands on them and then observed those individuals throughout the winter, confirmed that they were overwintering, recaptured them in March, and put on a nanotag. I specifically used the low-tech nanotag with a 5.9 second burst interval, meaning it's sending out its signal every 5.9 seconds. And because of the timing of those bursts, I could align 6 or 7 tags per location, per Motus tower, before they would potentially overlap and block each other's signal. That gave about a 3-month battery life, which would be long enough to get into the breeding season. So confirming overwintering by color banding, put the Motus tag on in March, and that gives 3 months into June when birds would be on their breeding territories. I did this over 2 winters. And the goal was to have 2 Motus stations with tagged birds each year. What happened? Didn't work out that way. Only got birds tagged at 1 Motus station each year, and then also put out some tags at a non-Motus site. So the Motus stations are receiving stations with large antennas. They're permanently fixed. Well, they don't move. They're stationary locations. And then as the bird moves through the landscape, it can be picked up by that station. That observation is recorded and then available, uploaded into a online database that's then available for download. Okay, so the first station was the one we put up in Hopkins Forest Motus Station. The star here is showing the location of the Motus Station right on the border with New York and Massachusetts. And then the winter banding location is shown by that white dot there. So that winter capture banding location is 3.8 kilometers to the east of the station. I deployed nanotags at that location in March 2023. The bird feeding station was not operational the following winter, this 2023-24, so I didn't tag any more birds at that location, so we only had one winter. And you can see that 3.8 kilometers pretty relatively close to that Motus station. And there's lots of breeding areas for juncos within that 15-kilometer detection zone. So I've shaded in red the areas where juncos are breeding, where I've confirmed they're breeding, or where there's higher elevation and it's likely that they're breeding in those locations. The second Motus station was at October Mountain State Forest in the center part of Berkshire County in western Massachusetts. There were some snags and delays, so this one wasn't installed in time for winter number 1, but was installed October 2023. And the banding station is 1.6 kilometers, so that white dot there, 1.6 kilometers to the east of the Motus station. I deployed nanotags here in the first winter, even though we didn't have a station, and then in March 2024. And lots of junco breeding habitat around that Motus station and banding station as well. This location the banding location was in breeding areas for juncos. At the Hopkins Forest, it was a slightly lower down slope, with the thought being that birds might be banded there and then move upslope, exhibiting altitudinal migration and potentially be detected at that ridgetop Motus station at Hopkins Forest. And then the non-Motus location was the MCLA campus for winter banding. We have juncos that visit our feeding station at campus each year. We don't have a Motus station, but we did couple some hand tracking to confirm locations at that area indicated by the star here. And both winters, March 23 and March 24, I deployed nanotags. So over the 2 winters, I deployed a total of 42 nanotags. And let me just emphasize first, the first bullet point here, no juncos were confirmed remaining near a Motus station from winter to spring. So none of the winter banded juncos were confirmed staying near the Motus station. So using the Motus technology, I was not able to confirm residency or altitudinal migration with the nanotagging. Not quite half of those tags. 19 of the tags were because I only had an operational Motus station and feeding station near the Motus tower in 1 year for each station. Only 19 of the tags were actually within the potential detection zone of the Motus station each year. However, 45% of the nanotag juncos were detected at a foreign Motus station. So none stayed around the Motus station, but 45% of the tags, 19 out of 42, were detected away from the site wherever they were banded. So of the juncos that were detected at other Motus stations, at foreign Motus stations, where did they go? Where did those 19 juncos go? Okay, so this is a little bit of a heavy-duty kind of full map here, but let me walk you through here. So we're looking at the northeastern U.S., southern Canada, and I'm only showing this range area here because that's the extent of where we had detections. So the star here in western Massachusetts shows our banding locations in western Massachusetts. The open circles show Motus stations where juncos or any other tagged bird could be detected. The filled circles, the yellow ones, are showing where juncos were detected in 2023, in spring migration 2023, and the orange ones are showing where juncos were detected in spring 2024. So the colored in circles are showing actual detections. And I'm only showing the end point, not the end point, but the most distant detection of those juncos. So many of these 19 detected juncos had multiple detections along their routes, but I'm just showing the farthest one from its banding location. Okay, So there are 19 here, and there's several that are overlapped here. For instance, this is Shelburne Farms up the Champlain Valley. 5 of our tagged Juncos were detected at that one station moving northward. Okay, and then I superimpose these red arrows to show the 2 general directions of movement. So the Motus detections show a predominantly due north movement. So this arrow going up the Champlain Valley up into southern Canada. Where they go from there, I have no idea. You can see the Motus stations, basically there are none getting out of southern Canada. And then the other direction is moving northeastward into central Maine and then points beyond. So those are 2 general patterns of movement, due north and then to the northeast. Okay, and none of the Juncos that moved were moved to a foreign Motus station and stayed there. There were no confirmations of that. These were just picked up maybe usually once, maybe twice, but usually just once, and then they kept moving on. Okay, one Junco made a westward movement. So actually, that last slide showed 18 of them. This is the 19th one. So there's one Junco that moved to the northwest, up to the northwest of Ottawa. The white line that's continuing westward, I think that's a false detection for a variety of reasons. This is probably not a real detection, but it did move to the northwest. Those are good detections up here northwest of Ottawa. So where that Junco is moving in that direction, beyond that, don't know, but there was one making a westward movement. Okay, so piecing together some of this here. So at least some of the Juncos overwintering in western Massachusetts are latitudinal migrants. So the birds that come here for the winter, at least some of them, approximately half of them from our data, go back northward to breed. Are there any staying all year? Well, I can't say that from the Motus data. However, I think there's some substantial limitations to the Motus technology for answering this question. I'm not sure that my methods can actually detect residency or altitudinal migration. I think they could, but everything would have to be perfect. So sort of as over the last 14 months I've been working and looking at the Motus data, I realized that there's some limitations to the Motus technology that I wasn't previously really appreciating. So let me zoom in here on an example. Here's the Hopkins Forest Motus Station, just on the border here with Massachusetts and New York. Notice with this topo map here, it's on a ridge. That's where we want the Motus stations. High up, clear view, better chances of detections of migrating birds. Okay, the yellow arrow here is showing our tagging location at the feeding station about 3.8 kilometers to the east. So not very far away, certainly within the 15 kilometers of detection radius. However, in between there, we have the ridge top, and then we've got this little valley here. But in between, we've got all of this other topography here. Plus, this landscape is completely forested. So it's likely that the signal is not making it to the tower consistently. Juncos also tend to hang out on the ground, so that also lowers the area where that signal being given off by the radio tag might be emitted. It's probably being blocked by topography. Even small-scale topography like a Junco foraging in a ditch, for instance, might be blocking that signal to the tower. So from that, I conclude that detections are not really consistent enough to conclude when birds are actually leaving the area. So that we only detected 45% at another station. Every bird stopped being detected at a station or with our handheld. But why did they stop? Is it because that they actually moved, or is it possible that they ducked into a valley here and just weren't detectable by the station? So let me show you an example of what the detection histories look like. So here's one tag being detected at Hopkins Forest. It was tagged, I think, on March 16th, 2023. And you can see it's not detected every day, and there's some gaps in the detections. So what's that bird doing in between? It's probably in the area and just not getting detections. We can look at the detection history in another way. So on the x-axis here, we're showing hours of the day, and 24 hours in the day, and then each row is a day, so 317, 318, 319, and then the red is showing when it was actually being picked up by that tower. So even within the course of a day, there's not consistent detections. It's really kind of, for lack of a better word, random or haphazard. So we don't really get detections that are consistent enough to make solid conclusions about if or when the bird left the area. So could this bird have actually been exhibiting altitudinal migration, but the blockage of the station, or by detections of the station by vegetation, bird behavior, and topography is completely possible. Or maybe this bird did fly north. We just don't know. So of the birds that weren't confirmed moving, 55% of the tags were not detected by another Motus station. So what happened to them? Well, it's possible that those birds moved and died. I don't think that's likely. Hand tracking, pretty intensive hand tracking at our non-Motus site, did reveal just one mortality over the 2 years. There's the Junco dead on the side of the road here. No idea what happened to it. And what's the more typical pattern is hand tracking the Juncos, and then they leave in a predictable pattern right when we would expect them to, basically in mid to late April when they're migrating away. However, of the 15 birds that were tagged at the MCLA site, only 5 were picked up by another Motus station after they left our hand tracking area. Where did they go? It's possible they went not very far at all and up in the mountains and were exhibiting altitudinal migration, but we just don't have the refinement in detection to do that. I did try a couple times driving around, but realized it was going to be, it would take a whole lot of luck to pick up a tag driving around on the many, many miles of roads, and then there's large areas that are just not accessible in western Massachusetts with a handheld receiver. So I quickly gave up on that. Okay, so what's another possibility? Well, birds that weren't detected by another Motus station, it's also possible they just moved through the landscape but weren't picked up by another tower. So here's one example of a movement from where it was banded here in western Massachusetts. This is a Junco that was only picked up by one tower here in southern Canada. But to get there, somehow it moved through New Hampshire, Vermont, somehow, the rest of other parts of southern Canada, and didn't get picked up by a station. I don't know how exactly that happens, but this is showing that somehow it is possible for the birds to migrate through the landscape and not get picked up by those stations. We had 45% detections. If we look at studied banding nano-tagging Juncos in southern Ohio, they're getting a much higher detection rate at foreign Motus stations, 65% or even higher. And if you look to the north, so all the Juncos in that area are moving because there are no breeders in that area of Ohio. So they're all moving northward, all migrating north. And if you look at southern Michigan, southern Ontario, there's a lot of saturation of stations in that landscape. So I think there's just a higher probability of the Juncos being detected there. Okay, well, so despite the limitations, Motus is still very useful for gathering movement information. Since 2017, I've banded over 1,000 Juncos and have had only 5 foreign recoveries that give us movement information, and those are typically migrants to potentially another migratory location. Whereas Motus is giving us 45%. And that's usually those birds are giving us multiple locations. So there's lots of great useful movement information. Maybe not so great for the residency altitudinal migration, at least at this point, but for movement information, it gives us lots of great information. So anyway, some of the next steps. I'm looking at trying to find locations for winter banding sites that are closer to the Motus towers that are also in breeding habitats. It's hard to do given the remote locations, and finding established bird feeders in the winter is kind of tough around the Motus stations, but that's one area I'm going to try to investigate a little further. I've also been nano-tagging summer breeders to see where they go, and that's currently in year 2, so stay tuned on that. And then moving forward in this, I'd like to integrate the banding, color banding, and isotope data with these Motus data to create a fuller picture of Junco migration. So we are getting bits of information from these different data streams, and putting those together might give us a fuller information picture of information of Junco migration in western Massachusetts, and then ultimately I'd kind of really hoping to find some morphological markers, maybe plumage color or wing shape, that might be able to distinguish between resident and migratory Juncos that are found in western Massachusetts and in this area between the latitudinal migrants and the residents to the south. Okay, so with that, I'll wrap up there, and feel free at any point to shoot me an email if you have any questions or want to talk anything about Juncos or Junco migration. Thanks for listening.